All right, welcome back on this link here. So we're going to start with the reporting back on the breakout sessions. And we have two breakouts. Actually, today it was great because I think we had good representations from MIT and Microsoft on each of the breakout and a balanced number of people too. So who wants to go first? And then just after the breakouts, then we'll keep the last 10 minutes to do a wrap up, close, and talk about possible next steps. So who wants to go first on the on the breakout, doing the report, and you have about 10 minutes.
Okay, I'm happy to go first. So Adam and I and Hadi, we were co-leading the adversarial robust ML session, and kind of the focus of the session was just try to understand, where do adversarial examples happen? What scenarios or threat models are realistic, and when we actually should worry about this problem right now, and we should kind of envision worrying about this problem down the line. And kind of the question was, again, we definitely do not have adversarial robust models yet. It's kind of like in ultimate way. But the question was, can we define some meaningful measure of progress on which kind of it might be modest level of robustness, but actually we feel that there is a meaningful progress happening. In particular, again, there are systems that are deployed right now, and you have to figure out, what do I do? I cannot wait 5 more years to see what will be the the greatest thing that this line of research can come up. I just need to do something now. What are the guarantees I should think about? How I should approach this problem in general? Okay. In particular, one important consideration was this setting of continual learning, like with spam detection or YouTube detection of YouTube fraudulent videos, where we do allow for kind of continual retraining of the model once new ways of bypassing it come about. So this is roughly I would say the space of what we wanted to kind of to survey and think about. And kind of the question was one of the goals was to kind of figure out what will be the analytically clean ways of modeling this kind of questions, kind of how can we have an analytically clean, simplified model that hopefully progress on this model will translate into actual real-world systems that are more robust. So in particular, one kind of, as usual, there was more questions than answers, but kind of, one particular kind of way of maybe breaking down this process a little bit was essentially to think about, kind of decouple the question of proximity measuring, like how can I measure if two inputs should be the same, semantically the same or not, from the task of being robust. So essentially the question would be, imagine I give you an oracle that tells you if these two inputs are semantically similar or not, okay? And again, designing this oracle alone can be quite challenging. Doesn't mean we are already done, or maybe the problem of robustness still remain. And the question is now, what would you need on top of that to actually solve this problem? So in particular, I think the belief is that it would not be enough, that the similarity is a very important part of the problem, but not end of it. And kind of there are things that come up in the context of sample complexity of the resulting methods and kind of dealing with the fact that just being able to query this oracle is not enough. But yeah, how would you detect that maybe your inputs are out of distribution? Because the understanding was that if something is out of distribution, you can't really expect your model to work well, and you would like to be able to flag it. But also, yeah, so there was a lot of questions around that. And in terms of implementing the oracle, maybe one thought was that if you kind of impose, and this is something that was happening in some of the previous work, is that if you impose some relatively simple notion of robustness to a visual system, like a pixel, being robust to small pixel-wide perturbations, it seems to actually make the perceptual similarity that the corresponding system measures actually be robust more than just for this kind of corruption. So this could be one way of hoping that you can bootstrap progress on specific notions of perturbing visual system to make them actual reliable estimates of this similarity. And essentially, so this was kind of roughly, what we are talking about. Maybe Adam or Hadi, if I forgot something, please pitch in.
So one additional thing I think we talked about as well is like it's really important to like study the robustness of the machine learning models like in the full system, because like when a model is in a full system, like it might be actually easier or more difficult for an attacker to attack it, for example. So it's really important like to look at end-to-end systems and like analyze like the robustness of models as being a part of the system, and maybe this will make it much easier for us to actually like rely on use machine learning reliably in the real world. And I think, yeah, Aleksander covered most of the stuff that I had taken notes on. So yeah, good job, Aleksander.
Yeah, that was a great discussion. Yeah, I think one of the points that everyone rallied around was the idea that that if we could sometimes give multiple possible answers, or say we're not sure, that would of course be better than giving wrong answers. But it was kind of a lively discussion, and there's some debate. It was interesting. There was a little debate about whether perturbations are enough, or for which applications perturbations are enough, and which applications should we look at, and what we can learn from the things that have already been out there for a really long time.
All right.
Go
ahead.
Okay. Oh, just a question about, I'm curious, I'm going to take a look at the notes, but did you discuss also about perturbations on the way how questions are phrased to a machine learning system? And that sometimes I may phrase the same question a little bit differently. Like I may ask, is there a dog in the picture? But I may also ask, is there an animal in the picture? And if the system tells me yes for the first and no for the second, this is some sort of other types of inconsistency that is not related to perturbing the input, but the question.
Yes, so we actually discussed this briefly, though. It's just like, yeah, the question is like exactly like, again, we want to have meaningful, like we would like to have guarantees that hold for all the inputs, not only for some of them. And then we are willing to essentially like, to compromise in terms of quality. Just a moment. Yes, so essentially, exactly as you say, it's like maybe I'm not able to say this is like a, poodle versus Labrador, but I am able to say, is it a dog versus a cat? Or I'm able to say, this is a living animal versus a car, and so on and so on. So we discussed this, and like, yeah, we actually like are working on this to figure out how much this helps. But yes, again, it's clear that something has to give if we want to have like, guarantees for all inputs. And the question is exactly how to phrase this, different levels of confidence and kind of in predictions.
Thanks.
So I think it's actually very interesting to think about these alternate displays. For example, in pattern recognition applications, a best practice might be to always have an abstraction hierarchy or ontology, and to, when things are when there's lack of confidence, to spread up to a point of a node of a class or a class of classes that's high probability, and say, look, I can give you distribution, but I know for sure that this is a mammal, or I know for sure this is the lymphoma. I can't tell you about the non-Hodgkin's and Hodgkin's version of it right now, or which non-Hodgkin's it is, but I know it's lymphoma. We don't think very much about that kind of thing in human AI collaboration. And I can say this: we haven't really, as a community, explored the richness of that space when it comes to. And this we'll get back to this a little bit next in the explanation notes, I think, as well.
Yeah, I agree.
We did talk about that briefly. There's a model of learning called conformal prediction, where you are allowed to kind of spread your prediction out among many different classes when you're not sure. And but yeah, I totally agree. It's not studied much at all. and it's a super interesting question.
Yeah, we're definitely an argmax space or argmin space, and that's the way we deal with things.
But I also think a lot of those questions are so interesting and maybe not even specific to adversarial machine learning. I mean, those are
the
just robustness. Yeah.
All right,
Arvind?
more questions, or are we switching to the next breakout?
Arvind, do you want to start and then I take over after your?
Sure. So Basmir and I led the interpretability, explainability breakout, and it was a really lively discussion, which was fantastic. I think we started with trying to get everyone's thoughts and reactions on the state of interpretability right now, and I think it's maybe fair to say that we all thought there was a fair ways to go. I think flailing around was certainly mentioned. Maybe I did prompt that, but I think that was the general sense of interpretability. And I think particularly what we homed in on was the fact that interpretability or explainability are terms that are poorly defined from multiple directions. For whom? What did these tasks look like? How does interpretability integrate into the broader workflow or decision process that people are thinking about, or even how does it integrate with other systems that are in place? So what is interpretability in the case of interoperability as well? Was something that was mentioned. I can keep going.
I can add a few thoughts, like a few notes from those. Something that came up as a theme was also the idea of designing systems and models for interpretability, in that a lot of work so far has been in explaining the current black boxes that we have built. But if we want to take a step back and actually design for better understanding, how would that look like? And there were examples that were given by both John and Daniela. Like Daniela mentioned a system that they are building where they're redefining the learning unit instead of like a step function to a function that learns differential equations. And they were able to show that they can learn the same concept with far fewer learning units. And so this raises a question about if I am to think on what is a system that can provide a better understanding, and then we can discuss whether the audience is the machine learning practitioner or the person who is taking a decision. Is there any revisiting or rethinking that we can do in the architecture level to support this? And this also resonated well with questions that Kathy raised on what does interpretability look like for complex reinforcement learning systems and online learners in sequential decision making, where there is perhaps no saliency map to look at, or that saliency map may change over time. And what would be the cartoonish picture of of the system architecture that can help us understand the interactions better?
I guess I'll add a final comment that I just want to amplify this opportunity space of thinking about machines that understand humans and what they know or need to know in a situation, as well as their own weaknesses when it comes to a specific case that the machine is executing on, to be able to talk about what is known, what is not known, to ideally optimize how to complement a human being. And in the middle of all that, coming up with the right displays for that information might be a useful thing to do. So the example was that the machine that knows what human beings can see about, let's say, a patient's physiology by just looking at them, and that it can't see, but it knows that it could see 10 years of lab history that the humans can't really process, and understanding how to sort of explain things from the point of view of what it's confident about, what it's not, given what it expects humans to be confident about, and custom tailoring explanations to ones that ideally augment where humans the primary decision maker, the human action.
Yeah, and riffing off of that, we had a really good discussion around the fact that the domain in which we study these questions can be really important, right? The degree to which, humans or user-centric considerations have been taken into account so far. They've primarily, not entirely, but primarily been in somewhat generic or crowdsourced settings. And so we had a nice conversation about, if we instantiate it in domains where the people that the participants in our user studies would have some skin in the game, so to speak. So in clinical settings, but it doesn't even need to necessarily be high stakes. Sid had a really nice example of studying interpretability with chess, where the skin in the game, so to speak, is, participants aren't playing chess against a machine because they know that, they know that the chess AI would be able to beat them regardless, right? We've got superhuman chess models, but rather they play chess because it's an enjoyable experience. And so they want to use interpretability as a way of improving their chess playing ability. So that's their kind of skin in the game. And that led us to a conversation about, could we look at literature and pedagogy and education science as a way of furthering interpretability as well.
Frederick, any other notes that we missed?
Yeah, I think you guys really got it. A couple other things is, I guess a lot of the beginning of the conversation was about different settings. What is interpretability really? Why do we care about it? So some other reasons people suggested is, for example, in a pharmaceutical application, if we were going to tell your boss, we should use this model instead of that model, they probably care a lot about, what is that model doing? And then another concern, which was a bit different from what we discussed later, was connections between interpretability and generalizability. Maybe is it the case that an interpretable model will extrapolate better, work better on data that's out of the training set? And that could be somehow that's a sort of different concern than some of the other things we discussed.
Yeah, I think what came up is that models are only useful when people use their outputs to change something, to make a decision that they affect the world in some way. And if we don't take that into account, it really doesn't matter how, quote, accurate our models are. And there was some, I think, discussion about potential trade-offs between accuracy and explainability of models, and models that humans could interact with in a productive way. I think there's a notion that we too often think of the model as something that exists all by itself. And those models aren't actually very interesting in practice.
Yeah, I think they're clearly, to me, several rich doctoral dissertations in this space that have not been written yet. And they wouldn't necessarily be on the qualitative side. They'd go down into the depths of some of the formal modeling and so on, and formal methods as well. And so I'm hoping that we see more of that kind of work at MIT. There are in the healthcare area, as John knows, and John and I probably had some of the early discussions about this. People are starting to do randomized clinical trials with a machine learning model sitting on the floor in the hospital, advising physicians in Wing A, where in Wing B, they don't have that system. They try to match the floors. They want to see what's the actual influence of this system on health, on quality of care. You can imagine backing that into different kinds of displays, different kinds of explanations, and so on as well.
Any further comments for this group?
Questions.
Questions, yes. Questions.
We have all the answers.
All right, I think we are going to move towards the last part of this day and today's. Actually, we're going to close the workshop. And for that, I will invite in a second Daniela and Eric and Aleksander to join. Not at the same time, just to be clear. But first of all, just want to thank everyone. I learned tons over the 2 days, both scientifically, I will say also logistically. I just want to emphasize that this is my first virtual event, and we've been between Teams Lives and team sessions and breakouts, and so learning a lot with all of you as we are in this situation right now with the pandemics. And that brings me to actually an ask to you, which is a survey. So we have a survey that Jen will send. Jen has been interacting with you during this workshop, also with the IT team. And so please do send us the feedback on the survey. This is really an opportunity for you, for all of us to learn, but also for you to talk about the good, the bad, and the wanted. We are, as I mentioned, we are learning about what works well, what are the opportunities. So we take this very seriously. It's a very short survey. It's I think it's 4 questions. There is some free text, so feel free to send critical, constructive feedback, and we'll of course take it into account for next events. So so with that, I mean, I really want to, again, I really thank all the speakers for contributing. And, you know, when we talked about the different medium that we used and doing the pre-recording and all of you to bear with us and all the communications. Overall, I think it went well. As I mentioned, I learned tons. And for the event itself, the logistic definitely wants to learn more. I just want to mention that actually we have an event. When you see the email from Jen asking for the survey, and you'll see also that there is an event that we are doing the 3rd week of July, a virtual event on frontiers in machine learning. There are some topics actually that you will find familiar, some of the ones that we have been discussing over those 2 days. There will be a link, and we invite all of you to register to that event, and you'll see more in that email that Jen will send. And then, of course, we want also to think about next steps. When we started looking at, specifically for the breakouts with Aleksander, we were thinking of how can we continue the conversation, what are other topics? And there too, actually, you were all fantastic as bringing many ideas in terms of topics that you would like to discuss. And we have, I think, just we've been looking at just like the icing of the iceberg here, the surface in terms of topics that we were able just to bring during these 2 days. So when you think about next steps, what are the topics that we would like to prioritize? And then I let Eric actually talk also about some of our next steps in terms of where how we could continue some of that conversation. But for now, I want to invite Daniela to thank you for joining us yesterday and today, and then your thoughts, reflections on the workshops, and share with us. Thank you, Daniela.
Thank you, Evelyne, and thank you to the entire Microsoft team and to Aleksander for organizing a fabulous event. I have enjoyed so much the talks. That means that our researchers have done tremendously interesting work, and this is really extraordinary. We started this program 2 years ago, and I think we have advanced the state of knowledge significantly with this team. So I learned a lot, like you, Evelyne. I've learned about Microsoft Teams in addition to the science. As I reflect upon the interesting conversations that took place in the breakout sessions and the results in the talk, I'm really excited and encouraged about a future where we have machines supporting people with cognitive tasks in more capable ways than they do today. And all the themes that have been brought up as part of this meeting are advancing this notion that the human is an important part of the equation between humans and machines. What machines do should support the human. And that means that a lot of the questions that we are asking should be phrased in a context that includes the human. Ultimately, we have to bring it down to mathematics because that's what we will end up modeling as computation. But it's so important to consider how we capture the humanity of this interaction as part of this discussion. And we have some nuggets of ideas. We certainly have a lot of opportunities to be creative and to advance the state of knowledge in the space. Ultimately, we should have machines and people working together, where together the system, machine, human is much more powerful than the human on his or her own, or the machines on their own. And this poses some interesting questions about what can we do to get machines that adapt to us rather than the other way around. I mean, so far we have been adapting to the models that we were able to make work with machines, but maybe we have reached a point where we can begin to think about doing this the other way around. There are so many interesting open problems about trust, about interpretation, about extrapolation, about generalizability, about what it means to fully close the loop. And I am excited for continuing our collaborations and for continuing these important discussions. So thank you very much. Thank you to Microsoft for organizing this awesome event, and also for your support of our research.
Thank you, Daniela. Thank you so much. Eric?
Yeah, thanks everybody. It's been a fun workshop. I enjoyed all the pieces, the keynotes, the lightning talks, maybe especially the chance to interact in more the manner that we'd be doing at the Stata Center if we didn't have this coronavirus 2 in our midst, SARS coronavirus 2. So at MSR, we typically, when we fund programs like this, we look for effective collaborations with the right set of people. I've been personally quite happy with how things are going with bringing together colleagues across the organizations on important topics. And one's right around making AI systems more trustworthy and robust. The topics, as Daniela pointed out, that are coming into view now, maybe beyond the evergreen topics, the critical ones that we've laid out early on, include taking a wider view on ML. Doesn't mean we have to give up the formal methods, but for both human AI collaboration as human and machines, machines and organizations, as well as larger systems that involve multiple ML components, chains of ML models, for example, as well as considering the larger, what I would call the machine learning life cycles, from data to models to evaluation, and then systems that live in the world over a lifespan. Those are kind of I think, topics coming to the fore. So we'll be doing this again, both to track the progress, pardon the dual use of the term, and I think that we look forward to your feedback, and we would like to get inputs on topics and directions. Now, well, I think as Daniela suggested 2 years ago, I think we were ahead of the curve, for the thematic constellation of topics we've drawn together in this collaboration. I think we'll be seeing more engagement now with the National Science Foundation standing up a center with the same name, essentially, of our collaboration. There are National Academy studies going on recently. The National Security Commission on AI, I mentioned yesterday, was putting out reports in this space, making recommendations for government uses of AI systems. CSTV, other groups doing reports. So there are going to be opportunities for engaging with the community more broadly. And I think that we should also be thinking about whether people, subsets of us, want to put together community events like AAAI Spring Symposia, NeurIPS workshops on specific topics. It'll be a lot of fun. So thanks, everybody. I've enjoyed the experience. Things seem to work okay. Actually, with less travel. Although I wouldn't give up the personal contact, I think, if I had the choice. So now to Alex.
Thank you, everyone. As always, it's fun to hear about what people are doing. It's just like, since we're over time, I will be just brief. Again, like the question always for me is what are the next steps? And I think one thing we discussed with Evelyne is to have like a AAAI workshop. Like in some ways, this seems like the right community because like I really think that, as Eric said, that we want to think of ML and even robust ML broader than just about like, getting some models that are, more robust to L2 perturbation or something. And I think we really need to feel like it needs to be a broader tent effort that kind of brings together a lot of people who will use AI and kind of might not even be, they might be more of consumers of that as opposed to people who would contribute to it directly. So we are definitely thinking of like putting a proposal for a AAAI workshop. But like other than that, again, there is this like TRAC collaboration happening, but some of you are not formally part of this collaboration yet, and I think you would fit lovely there. So for now, like I hope both the talks and the breakout session was a good way to also identify who else might be interested in topics similar to you, and in particular, I'm a big believer into the MSR versus MIT kind of collaboration because I think there's a lot of complementary expertise coming in there. I'm enjoying my collaboration with my MSR colleagues quite a bit. So all I'm just saying is that, so beyond the AAAI workshop, beyond this Frontiers of ML event that Evelyne mentioned, that you are, I believe, all invited to, there is also like, opportunity to kind of start collaborations with people at Microsoft and vice versa. So, you probably know who these people are. You can just email them, but I'm also happy to help with like, matching an intro. If you say, oh, this topic was mentioned and I'm actually interested in that, who would be a good contact for that on the other side? I and Evelyne are happy to be this kind of matchmakers too. So just like essentially, it's very clear to me that there is much more to be done here. And I think, what we already accomplished is pretty promising. So so you are all welcome to engage.
Will the recorded talks be available so we can share them with our students, for example?
Yes, they will.
Yes.
So they will. So essentially, like, you can catch up on everything you missed if you missed something, and definitely students kind of can look at it. And in the end, like students are the ones who always are the drivers of the new collaborations. And again, all I'm just saying is that like we try to keep things, especially the breakout session, on a high level because I think it's more still about the questions than about the solutions here. So
maybe I can also add, we hope to welcome everyone on campus in a year's time. And so this is being very optimistic about how the world is going to evolve in the next 12 months. And in the meantime, we have a lot to work on in the space that we have identified, but we also have the opportunity to figure out what is coming, what is around the corner. And so I would love to see some thinking going in that direction as well.
So I guess that's all, and so thank you so much for coming, and it was really fun, and let's stay in touch and please stay safe and healthy with all that's happening. But looking forward.
Thanks everybody.
To connecting with you.
Thank you. Bye.
Thank you, everyone.